Next time you walk into like a massive sports bar on a Sunday, just look around. You expect visual perfection.
Oh, yeah, absolutely. Dozens of screens, zero lag. It's just expected.
Right, we usually just treat it like magic. But today, our mission for this deep dive is to look at the hidden backbone keeping that magic alive. The physical infrastructure running behind the walls is, well, it's completely invisible to us.
Right. We rarely even think about it.
Exactly. So we're looking at a massive catalog from a company called HDTVSupply. And I actually started out looking at this heavy-duty power conditioner from SurgeX.
Yeah, the SA-162, I think.
Right, the SA-162 standalone surge eliminator with CE-77 receptacles, basically an industrial-strength surge protector. But you quickly realize that unit is just guarding the actual brain of the operation. Okay, let's unpack this, because to run hundreds of screens at once, you need a highly specialized piece of hardware, right?
Yeah, you need a matrix switcher. The catalog focuses heavily on these Wolfpack modular matrix switchers. We're talking about routing high-definition video to up to 160 TVs at the exact same time.
That's just wild.
It is. And it's usually controlled by these custom tablets they call Wolfpads, and they integrate directly with, like, the DirecTV app.
Which just sounds like a total processing nightmare. I mean, if I hook up two monitors to my laptop, it completely struggles. How does a sports bar take a dozen different satellite feeds and blast them across 160 screens without the resolution looking like a blurry mess? Like, how does it not crash?
Well, what's fascinating here is how the matrix switcher actually handles the data. It's not just passively splitting a video signal the way a cheap cable splitter does,
Oh, right, because that just divides the bandwidth and ruins the picture.
Exactly. It's actually an active computer that rebuilds the image for every single output.
Yeah.
So if you have, say, a picture-in-picture or a picture-outside-picture setup, or even a massive video wall from a 1x2 up to a 10x1 configuration, the switcher's internal processor calculates the exact pixels needed for each specific screen.
Oh, wow. Okay.
Yeah, so it maintains pristine 4K quality across the whole array.
So it's less like a mirror reflecting one image and more like an artist instantly repainting the picture for every single frame on every single TV.
Yeah, that's a great way to put it. I mean, it's rebuilding the digital data packets in real time. And because it's so precise and robust, you start seeing this exact same tech in very different environments.
Yeah, and here's where it gets really interesting. Because the catalog features this massive section dedicated entirely to government purchasing.
Which is pretty surprising at first glance.
Right. They specifically list NASA's SETJB program, GSA schedules, and TAA-approved products from hundreds of partner brands, from AJA to Yamaha. And for you listening, those are incredibly strict federal standards that prove a product is secure and reliable enough for government or military use. But why is the military buying the exact same AV gear as a local sports pub?
Well, if we connect this to the bigger picture, it really comes down to scale and economics. Decades ago, if you wanted zero latency, flawless video routing for, say, a satellite command center, the government had to build it from scratch.
Which I imagine was insanely expensive.
Oh, unbelievably expensive. But today, the massive commercial demand for entertainment, think giant stadiums and sports bars, has basically funded the R&D. Extreme scale in the commercial sector has driven the cost of military-grade reliability down to consumer prices.
That's a huge shift. Entertainment literally bankrolled the infrastructure for aerospace tracking. But I have to push back here for a second. So what does this all mean for security? The catalog mentions a shift away from standard HDMI cords toward AV over IP, which is sending video over network cables. If a command center is ditching direct physical HDMI cords and throwing secure video onto a computer network, isn't that a massive vulnerability?
That's a really fair point. And this raises an important question, and it's exactly why those government certifications you mentioned earlier are non-negotiable. The shift toward AV air over IP matrix systems and 8K HDMI extenders doesn't mean broadcasting on the open internet.
Oh, okay.
Right. It digitizes the video signal, encrypts it, and then routes it over closed, dedicated local networks using standard Ethernet cables, like LAN or KD6.
Okay, so it's like shipping containers. Instead of building one massive continuous water pipe, which would be your traditional HDMI cable, you're packing the video data into secure, standardized shipping containers.
Yes, exactly.
And then you're just sending them across an existing freight network.
That's a perfect way to look at it.
Yeah.
And that standardized network architecture is what allows for this infinite scale.
Because you aren't limited by the, 50-foot maximum range of a regular HDMI cable?
Right. You can send pristine 4K or even 8K video hundreds of feet across an entire facility just by plugging into the network switch in the wall.
That is wild. So for you listening, the next time you're standing in an airport or, a massive public facility with a seamless video wall, you're not just looking at a bunch of TVs. You're looking at a deeply complex Wolfpack matrix system, safely hidden in a server rack, pushing massive data packets over the same kind of standard network cables that run your office.
It definitely makes you view commercial architecture differently. I mean, the walls are basically alive now, and it leaves you with something to consider. Now that AV over IP makes scaling screens infinitely easier and cheaper, how long until we hit a tipping point?
What kind of tip?
Or a tipping point where digital connected surfaces actually outnumber physical static walls in our public spaces?